In this video, actually we are going to see about the operator interfaces. How the operator interfaces are acting on your DCS plant, that is distributed control system plant. Generally, when you are talking about this operator interface, actually it is related to the automation system. So while you are going for automation system, in the automation area, the functions are requiring of the operation of the industrial process. So how this could be safe and effective manner, this is absolutely, it should be free from errors. So whatever the people are going to work in that particular field, they should be well engineered, and not only that, they should have a proper knowledge. So generally there are two groups of people of plant personnel interact with the control system. So who are all they? The first one is nothing but instrumentation and control system engineer. The next one is plant operator. So what is the role of instrumentation and control system engineer? These people are the responsibility of adjusting, maintaining time to time the values. Then plant operator, they are nothing but the people responsible for monitoring, supervising and running the process. So those are the people are just go around all the time in the plant. So whether the plant is going to start up or it is in the operation or shut down. So those things are the responsible of the plant operator. But the engineers, they used to do the adjusting the values, maintaining time to time. So when you are coming for the generalized distributed system, the human interface capability is providing two level. One is low level human interface, that is LLHI. The another one is high level human interface, that is high level human interface. So low level human interface, which is nothing but we are just connecting local control unit or your data input output through the cabling. High level in the sense, it is nothing but it is always connected via shared communication. That is the difference between LLHI and HLHI. So these are the two important levels we have in the generalized DCS system. So when you are coming to low level, actually it is fully related to panel board instrumentation. So panel board instrumentation, which is nothing but stations, indicator and the recorder. So these things are used in the conventional analog control system. HLHI, which is nothing but the latest display technology. So the latest technology, human HMI interface we used to call. And the olden days, the people used to have CRT or flat panel display. Then they are coming into printer and the magnetic storage that are available in the market. Not only that, when you are coming to system configuration, LLHI, that is local level human interface, they are located close to LCU, local control unit, or else your data input output. It's like 100 to 200 feet. That was the distance. But when you are coming to HLHI, they are located anywhere in the plant. And not only that, they are inclusion of your central control room. So they will determine the installation. It required one level or two levels of interface. So based on that, they will configure. Then comes to the next part. We have a small and simple installation, that is nothing but you have an LCU, that LCU which is placed in the equipment room. So that is called relay room. And not only that, the complete operator and the instrument engineer interface for the control room. So they will be taking the decision. And this type of equipment configuration is stand-alone control system. And not only that, they are called as a small process or small DCS. So your plant is controlled primarily with conventional electrical analog or pneumatic. Olden days they are operated with a pneumatic, then they are coming into electrical, and nowadays they are moving into a SCADA. Then this is what you are structured for standalone control, which consists of three things: your control room, equipment room, and the area. So the plant area, which is the one we used to call as a process, equipment room, which consists of LCU with low level human interface. Then your control room is again low level human interface. So LLHI is used in the control room as well as equipment room. The next one is called a complete plant-wide control system. So in that we are using so many LCU unit, and they are located equipment room area, and they are acting like an distributed. And here this low level interfaces include in the configuration to serve as a backup in case of your high level. This is what the geographical centralized one. So your geographical centralized one, which consists of control room, then we have an equipment, then engineering area. So your engineering area, it's fully concentrate on high level human interface. Equipment room, which consists of the shared communication via local control unit, and your control room, which also consists of HLHI along with LLHI. Then your plant area consists of the process. So when you are looking at both the blocks of control room and the instrument engineering area, HLHI is there. So HLHI, which is situated for both your instrument engineer along with the control room. Only the equipment room we have so many local control units. So why we have so many local control unit? If any one of the thing is getting failure, other thing will get like backup. So if there is any possibility of error comes. Then comes to next one, your high level human locate instrument area so that he can able to monitor and analyze without disturbing the plant operation. So that is the reason why we have an HLHI interface in the instrument engineering area. And the next one is about fully distributed. So fully distributed, here we have LCU, and which is located in the plant area and close to the portion of the process. Not only that, they are associated with low level human interface equipment. So here the control room and the instrument engineering area contains high level used to perform all the primary operation and the engineering function. Not only that, any failure, some of the unit will act like a backup. So they will maintain according to the operation. And using of this, there are two advantages. One is reduction in size, that is control room size. Next one is reduction in field wiring concepts. So these are the two advantages while you are going for this particular example. And the next one is about the human interface equipment is designed to meet out some wide ranges of application, large as well as small, both the things we can use. And we have a centralized equipment configuration, and in which we have so many units like control room, instrument engineering area, plant area, and then process. So your plant area, which consists of LCU, LLHI, and these LLHI are the optional one. So your engineering area, which consists HLHI. So this is like a geographically distributed. Why? Geographically distributed means each unit will have a longer distance, so you can able to perform as it like. So this is what this particular block. The next one is about the requirement. So what are the operator interface requirements we have? So the requirements like, because the main function of the operator is monitoring the process. Whatever may be the variable, he has to observe and monitor the status of the process. So for that particular reason, we were in need of so many specific requirements. So the requirements are like the current value of the process variable. So the operator has to view at all the time. So it is like a continuous process. So the person has to be there. The next one is rather being identified by the address, they should have a tag. So from the tag they can be able to identify the descriptor, whether the particular value is, for example, TT075. TT, which is nothing but temperature, and the area they used to indicate like some letters. Then 75 is a value. So they will have some tags usage. So the particular engineer can able to identify the position. So second requirement is nothing but the tag one, and the first one is the current value. So the operator should be available at all the time. Then third one is about whatever the variable they are indicating, it should be like an engineering unit. Then only they can able to understand. Then the next one is about the variable. So what variable they are using, whether it is basic or not. Then after monitoring those things, they can able to detect the abnormality which is present in the whole process. Then only they can able to take the action. So some of the specific requirements are like to reporting, the simplest form if you are given, the engineer can able to communicate that particular thing to the operator. So the requirements are like control and computing, that is like they can report the status of the operator. It's in the form of alarm. The alarms are high, low and deviation. So they will that fix it from the nominal value and it should be differentiated. Then the next one is like alarm status, and the operator interface either display the alarm limit. Then not only that, they can acknowledge the thing. Then multiple alarm conditions, it's like in prioritized values and the current value as well as the trending values they have. So they are called it as a trend variable, and it should be like grouping the trending variable relate to process, or it's like a graph, or it's like a precise reading, or the graph displaying the trend should also using auxiliary information. So these values, they are again based on the operator specific interface requirement. They are categorizing in terms of the process control. It's like continuous control group and logic sequence. Then changing control, either you are going for automatic, manual or cascade. Then it's like an interfacing facility, whether they are going for interlocking operation. Interlocking the sense your operation is based on starting or stopping the pump. It is like an interlocking signals, or the process is in batch control sequence. So based on that, they are just monitoring capabilities they have described in the operator console. So the operator interface requirement should be like that. So they are just categorizing based on process control. The next one is about the diagnostic. Diagnostic, which is nothing but monitoring and controlling the process under operating condition. So what are all the tests we have? Ongoing test, then ongoing self-test. Ongoing test in the sense if there is any problem comes on the sensor and the analyzer part. Self-test, which is nothing but within the system or the controller or the computing device. So these things called as an diagnostics. Then comes to these functions for the diagnostic purpose, how the communicating. The first one is like first alarming, that is only first sequence of alarm, then prioritized based alarm, then advanced based alarm. So based on these three operations, they can able to ranking the thing and the information will communicate to the operator. The next one is about the process record keeping. So whatever the information they are doing, that will be record, and whenever the operator or whatever the person is going to the plant, they have a board along with the pencil and the clipboard. So periodically they will take the data and they will take note out, and the current value and the process variable, that will be called as a logged information. So the logged information along with the record, they will obtain automatically. It will be like useful record of the plant operating status during each shift, because in the plant per day there will be 3 shifts. So each person has to communicate with the data. That is the reason they have